Hi, today we're going to learn about arcs and chords in circles. Theorem 9-4 says that in the same circle or in congruent circles, congruent chords will have congruent arcs, and congruent arcs will have congruent. Here's an example. Asked to name the congruent arcs in the diagram. Both arc AB and BC are subtended by a chord that is 10 units in length. Therefore, AB and BC would be congruent arcs. Here's another example. This one asks us to name the congruent chords in the diagram. You can see that there are 3 arcs that are labeled. JK is 85 degrees, GH is 95 degrees, and ST is 85. You can tell 2 of them are both 85. They are going to be the congruent chords. So JK and ST are congruent chords. Our next theorem, 9-5, says a diameter that is perpendicular to a chord is going to bisect the chord and its arc. Here's an example. Diameter that is drawn in this circle is DE, and it is perpendicular to chord FG. If the measure of arc FDG, that's the major arc, is 250 degrees, then we are asked to find the measure of arc FG and arc FE. For FG, that's a minor arc, and that arc together with arc FDG makes a complete circle, which is 360. So we just take 360 and subtract 250 to get 110 degrees for arc FG. Arc FE is half of arc FG by the theorem that we just read. If a diameter is perpendicular to a chord, it bisects that chord and its arc. So FE would be half of 110 degrees, which would be 55 degrees. And our last part, if the chord FG is 16, again, the chord is split in half by the diameter because it's perpendicular. So FH would be 8, and so would GH. Theorem 9-6 says in the same circle or in congruent circles, congruent chords are the same distance from the center, and chords that are equally distant from the center are congruent. You can see they're basically saying the same thing, just in reverse. And note, the closer you get to the center of the circle, the larger the chord gets. Remember that the diameter is always the longest chord in the circle. Example 4. We have circle O. We want to name 2 congruent chords. You can see both chord VW and ZY are 6 units from the center. And the theorem just said that chords that are the same distance from the center are the same. So VW and ZY are congruent chords. Now let's calculate some measurements. AW is part of a right triangle, AOW, and it has sides of 6 and a hypotenuse of 10. We can use the Pythagorean theorem to come up with AW. That's one of our Pythagorean triples. AW would be 8. That means VW from the last theorem, AW and VA have to be the same. A is a midpoint, so VW would be 16. And then BZ, since chord ZY is the same distance from the center as VW, and they're congruent, BZ would be the same as AW. And then OY. OY is another radius. Even though it's not drawn in, you can connect OY and it would be a radius. So that would be 10, the same as OW. And then ZY would be 16 because BZ and BY would both be 8. Hope you enjoyed learning about arcs and chords in circles.